Morning, everybody. Sorry about that. We had to reset the computer that beams everything out. So if you don't mind giving us a green check if you can see and hear. Abby was mentioning she had some issues with the audio, but it seems like everyone else can see and hear me okay. So if that's the case, then we'll just continue on. If not, we can address more issues that we might have. Excellent, we've got lots of green check marks, so that's good. Just on the off chance that Abby can't see me or hear me, I'll just type something into chat for her. All right, I don't have a ton planned for today. I just want to go over a few things with you guys. If you have any questions, as always, just fire them into chat, but just want to make sure that you guys are all, oh boy, you're all on board and understand what's going to go on this week. We have a couple things happening, obviously provincial exam and some other stuff, so I'm just going to give everybody a chance to chime in and chat, and then we will... Okay. Avery, it's due today, so you have time. I'll go through that. If you guys have any questions as I go through this, let me know, but I hope to go and answer all of your questions. Essentially, everything that you've done should be finished now. We had our kind of mark cut off on Friday. So any assignments, tests, reviews, assignments should all be complete and submitted. Your final review is due today, so you had choice 1, 2, 3, or 4. And it's really important that you check your grades and make sure that I haven't missed anything marked, missed marking things or anything like that. And I want you guys to make sure that you let me know if there's something that looks a little bit funny. And if maybe along the way I said, hey, I'd omit that for you or something like that. There were some labs that didn't work out and some other things that kind of happened along the course. So if there's something like that that's happened and it doesn't look like it's reflected in your mark, don't hesitate to send me a message and say, hey, Mr. Borden, please remember to omit this, or this looks like it hasn't been marked yet, but I submitted it a long time ago, something like that. And we can deal with that. My marks are due on Wednesday, so we do have a couple days to kind of make sure that everything's good, but I want to make sure that you guys' grades are exactly where they should be. And basically at the end of the day today, I'm just going to kind of lock everything. And that will allow me to get your grades finalized without things changing on me, because as soon as you guys, if you were to go in and write a test or something after, it would affect your mark, and I want to make sure I have the right mark in there. So that's the first thing with your grades. Taylor, I see your question. I'll get to that in a second. Final exam. This is what we've been working up towards. I'm talking about the provincial exam now, not the final review from the course. So it's this Friday, and it's at 1 o'clock at Hollywood Education Center. And that's where we wrote our midterm and had the Heritage Fair, this class one. So you guys need to show up about 15 minutes early. That just gets you sitting down in the right seat. You got to find your test, and then basically you have to sign a form, and we'll give you some stickers to put on your test booklet and your answer booklet. And you have to stay for at least 1 hour. I forgot to write it in here, but you can show up 30 minutes late. So if you show up at 1:31, you're not allowed to write the test. If you show up at 1:29, you're allowed to write the test. You have to stay for an hour. So if you are going to, just finish right away, you have to stay for an hour. So at the minimum time you have to sit in that room is an hour. You get up to 3 hours. The test is designed for 2 hours. It's 80 questions, multiple choice, no written, no nothing else. And you just have to be there for an hour. So if your parents are coming to pick you up, 4 p.m. would be the latest you could write the test. So We hope to get everything started on time and finished on time. You will need a pencil because it's a paper exam. You have to bubble in the circles, so pencil. And you'll need a calculator for the physics unit for some of the radiation stuff as well. And you can bring water and a snack or whatever you want. We'll have somebody be at the front door. We're not in the same room as we were before. Unfortunately, we couldn't get that one. We have one at the back of the building, so it'll just be a bit quieter. Not that it's a super noisy room. And anyways, that is this Friday. Does anybody have any questions about the final? I see you have a question there, Abby. You're asking about the exam, the practice exam, or the review. It's due today at the end of the day. And how much is it worth? I think it's worth something like 7 to 10%. I don't remember exactly what it's in as. So that is the final exam. Nobody seems to have any questions about that. We'll just keep on rolling. The final review. So this is any last questions you might have on Wednesday this week from 1 to 3 at McWilliams Center, so where we broadcast and meet out here. If you have any questions, you can come in and ask, and I'll just be here and be able to help you guys out. Well, if you are going to come, you just want to send me a message in Moodle or an email or something, just so we know how many people to expect. You're not required to come, but if there is anything you have questions about or something that you didn't get along the way, I'd be happy to go over it there. As well, if you want to look at some additional material, I have old tests from all the sections and worksheets and all sorts of stuff. So if you have anything that you might want to go over in person instead of online, this would be the last chance to see me. Would be on Wednesday from 1 to 3 at McWilliams Center downtown. With the final reviews, I'll go over those in a second, but I hope to, it just depends on which choice you picked. If you pick one of the exams, I will mark it and I'll give you the correct answer, and then I will send it back to you so you can look at it. And then if you were to do the workbook with all the questions in it, I'll go through and mark all the questions and make sure that you've got all the right answers in there. And then if you did the in-class exam, choice number 4, the one that's kind of built into the course, the multiple choice will be marked for you. I'll mark the written, and then I'll give it back to you. So I hope by hopefully the end of the day tomorrow, I'll have the solutions to anything you submit for me. And I think I'll post the answers to the tests just in general. So even if you didn't write, choice number 2, and you want to go back and look at it, I'll put the answers to choice number 2 up. So you can use that as an additional piece of review if you want, or just to, check some questions and things like that. So I'll mark whatever you submit to me, I'll mark it, give you the correct answers back. The other choices, if you didn't pick them, that's fine, but I'll give you the answers to those as well. And that's kind of that. Does anybody have any questions about that? I see a bunch more questions or statements coming in here. For the practice provincial, I use a sheet of paper. Yes, that's fine. So if you had like 1A, 2B, 3B, 4C, I can go through and just mark that. And I said this before, I said if you want to include any written work that you did along the way with the practice exams, the practice provincials, I can look at the work you've done and say, oh, it looks like you forgot this number, whatever. There's only a few questions that might be like that, but something like balancing or things like that, I could find some mistakes in your work if there are any, and help you out there. Yeah, I know printing off like a 50-page exam and then submitting that again is a lot of work. So if you did it in a Word document, that's okay. I don't really care which way you do it, as long as it's kind of obvious which answers you've chosen. I can mark it and give it back to you. So hopefully that makes sense. There you go. So that's kind of all I wanted to say about that. Ava, you're right. The combustion ones is tricky, but the good news with combustion is once you figure out that you have a combustion, basically you're going to go through it and it's not going to work out, and then you just double everything and then it will work out. That's kind of the trick with the combustions. You'll see that there's a bit of a pattern for those. All right. It's not going forward. Oh, there we go. I only made those 3 slides. I want to say with the final reviews, choice 1, 2, 3, or 4, I had something else written, I guess I forgot to include it. If you had any specific questions from the reviews, I'd be happy to go through that now. I might not just tell you the answer outright, but I can help you, if you have any questions that came up while going through the final reviews or anything else for that matter. I don't have anything planned for today, so you guys have been working hard and you guys have worked hard all semester to get this far. So if you do have specific questions, let me know what you're asking off of the choices or a learning guide in the past or an old test or something, and I can go in and try to figure it out. And basically, I don't really have anything additional to say. The important stuff is everything was due on Friday last week. Your final review is due today at the end of the day, so I leave here at 3:30 or whatever. I will come and check the grades tomorrow morning. So that's that. Marks will be kind of cut off today. Everything will kind of be finalized. And if you want to come in on Wednesday, 1 to 3, final exams on Friday at 1 at Hollywood Road. And that's it. So if none of that applies to you, you got it all under control, you don't want to sit and watch me do any problems that anybody had, you're free to go. I will see you for sure on Friday. And if you come in on Wednesday, I'll see you then as well. So that's that. If you want to stick around and ask some specific questions from any of the practice provincials, reviews, anything like that, I'd be happy to do that now. So as long as there's questions, I'll stick around. If everybody's questionless, then we'll call it an afternoon and or a day, I guess, and you guys can just work away at your practice exam. So, Abby, I got that. Okay, so Abby's got some questions. If you have some additional questions, let me know. The one that starts with decomposers. Let's see if I have it loaded in here. Practice, I don't believe this is it. This is the one I went over in class. This is the year in review. This is not the one you're talking about. This may be the one you're talking about. This looks like it's starting with decomposers. Okay, Abby. Question 1, 14, 28, 38, and 42. Perfect. So decomposers are the main source of energy for... This is a kind of a tricky question, I guess. Decomposers are the source of energy for. So it's kind of a bit of a backwards type of question. You're always going to have decomposers. And decomposers feed on all levels of the food chain. So yeah, it's neither. Decomposers aren't the source of energy for either. So the source of energy from both food chains is going to be the sun, if you want to look at it at a very basic level. The bottom of all food chains is going to have some sort of photosynthetic thing. So you're right on that for sure. There were some more questions in here. 14, 28, 38. Let's go down to 14. 14 says, as a result of the deforestation of a tropical rainforest is an increase in... This is kind of like the question Ava asked the other day about the other exam. Sorry, I just got your other question here, Abby. What are decomposers? So decomposers are detrivores, same thing. They feed on dead or decaying plants and animal matter. They are kind of what recycles everything, all the nutrients in the food chain. So your decomposers are things like beetles and maggots and bacteria are good decomposers. So they take things that are dead, they consume them, release the nutrients back into the soil to get absorbed by plants. As a result of deforestation of a tropical rainforest is an increase of... Okay. Did you want to put in the correct numbers or letters, or sorry, yeah, numbers, and I can do that. Tropical deforestation gets rid of biodiversity. Trees are a carbon store, so we don't want that. Oxygen would... I'm thinking it's probably C. Yeah, Ava, I would agree with you on that. And again, that's probably the most correct answer out of them. You could make arguments for the rest of them, but we talked about that specifically. When you take away the trees, the root systems disappear, and then you have rain, and then the soil runs off. And then you end up with issues with the soil. If you don't have soil, you can't grow plants. And then you have to start primary succession all over again, which is... yeah, that was definitely one of the topics right out of the book, so for sure. 20, 54, and 68. All right. Population of squirrels migrated to an area where there's very little competition. If the population of squirrels increased and then stabilized, which of the following statements explains why the population leveled off? So I guess we have a little graph here showing the number of squirrels entering an area, and then it kind of levels off here. The squirrel stopped reproducing, and that's not likely. Why would an animal stop reproducing? There were no known predators to the squirrels in this area. It's plausible. Predators of the squirrels occupied the same niche as the squirrels. A limited amount of food and shelter was available to the squirrels. So we know it's not A, and it's likely not B, because if there was no known predators, then the population probably would have increased a lot. Looking at answers C or D, those are pretty interesting. If the predators occupied the same niche, would the population of squirrels increased and then leveled off? What would be the sort of cause and effect relationship between the predators and the squirrels? If the predators were there in the same niche, then the squirrel population probably wouldn't have increased initially, because there would have been a lot of competition for resources, the shelter. I would say if the predators were in the same niche, your population probably would have done something like this, just stayed kind of level. I like answer D because initially there's a bunch of food and a bunch of shelter, and then once the population increased to a certain point, you run into problems with food and shelter. There's not enough food to support a population size any larger. So there was very little competition. I suppose I would see that in kind of the past tense. And competition, generally speaking, we talk about competition as being between different organisms. So the population of squirrels migrated to an area where there was very little competition. I would definitely go with D on that one. So because they reached the carrying capacity of the ecosystem, or they ran out of food and shelter, you would run into issues with that sort of thing. 54, 3, 4. Which position time graph shows a constant negative velocity? The important idea here is to remember that slope of a position time graph equals velocity. And in this case, we need to have a negative slope, which would be a negative velocity. So the only one that has a negative slope is B. Everything else is, this is a positive slope, this is a positive slope, this is zero slope. So I'm going with B unless anybody has anything to say about it. I guess you might be a bit confused with letter C if you're thinking of a velocity time graph. This would be a negative velocity, but it's important to recognize that this is a position time graph, not a velocity time graph. What does it mean when it is in the negative quadrant? All right, let's think of it this way. Let's just put some numbers in here. That's positive 5, that's negative 5. In the middle we have 0. I could draw like a little picture here. Here's 0, here's positive 5, here's negative 5. So at some time, our object started at negative 5. Let's draw a little ball. Sometime later, it was at, I don't know, negative 2 maybe. So now the object's here, and then it looks like it's working its way along towards the tree. And it ends just before it gets to 0, but it's just moving towards there. What do we call that? Well, if we were to find the slope would be rise over run. It definitely have a positive slope, so it would be a position time graph. We just say that an object's moving in a forward direction towards some initial position, some initial object. I think you're probably getting position time graphs and velocity time graphs mixed up. A velocity time graph would be something completely different. Because these are all position time graphs, it's just an object starting at negative 5 meters. I made that number up, but it's starting to the left and it's moving back towards some starting initial position or some 0 position. Hopefully that squares that one away. Yeah, definitely, Abby. Number 68 is just a basic vocab thing. It's seen if you know the difference between the epicenter and the focus. Does anybody remember the difference between... Okay, Avery, thanks. I'll get to that for sure. Does anybody know the difference between epicenter and focus? Which one's which? Because this one is asking specifically about the focus. And of course, epicenter and focus are closely related, but slightly different. So what do we have happening here? The focus of the earthquake. First of all, A doesn't really make sense. It's not really showing anything. And like D is way over here, which kind of doesn't make sense either. So epicenter and the focus. I think the focus is the actual spot on the ground and the epicenter is the spot on Earth's surface, or is that backwards? I can't remember, to be honest with you. Somebody else remember? I could go look it up. I don't have a unit 10 in here. Epicenter is, I'm pretty sure the epicenter would be C in this case, and the focus would be B. The focus is the spot on the ground, and the epicenter is the surface. Unit 9876432 I don't know why I don't have unit 10 loaded in here. So the focus is where the pressure gets released, and then this is the epicenter. I'm pretty sure that's the correct one. Somebody can go look it up and come back and tell us. I don't want to tell you the wrong thing. I'm pretty confident that's right, though. The B is the focus and C is the epicenter, as opposed to the other way around. I don't want to tell you and be uncertain about it, though. Yeah, that's kind of what I'm thinking about as well, Abby. When you talk about earthquakes in the news, you say the epicenter was 10 kilometers south of Vancouver, or 40 kilometers west. We don't usually talk about where the actual earthquake occurred. I'm going to go with that, and if I was wrong on that, I'll look it up later and tell you, but unless you hear otherwise, that's what it is. So we'll go with that. There's a few more questions on the same test. 68, 73, and 78. Best evidence for crustal movement at the Mariana Trench is the presence of... it's not even referring to that. Now, this isn't one of those questions where... thank you, Avery. Not just for telling me I'm right, but thank you for checking. This is one of those questions where you are going to have to look to your learning guide I keep calling it the learning guide, your data booklet, and you're going to have to find the Mariana Trench. So I don't see it there, and hopefully it's here somewhere. I would find it really difficult to believe they would ask you about the Mariana Trench and not tell you about it. Oh, it's referring to the previous page? That makes sense. There's the Mariana Trench, 71 to 73. That makes way more sense. They're not going to ask you to memorize where that is. So Mariana Trench, you can see it's happening at these little triangles, remember, mean a subduction zone. So you have one plate going under the other. Trenches occur where you have subduction. And let's reread the question again. Best evidence for crustal movement at the Mariana Trench is the presence of a rift valley. Well, a trench is happening at a subduction zone, so that doesn't make sense. A spreading ridge is a rift valley on land. Hotspot volcanoes and shallow, medium, and deep focus earthquakes. So I'm going to think it's either C or D. Or sorry, not C at all. Hotspot volcano, remember, is if you have a plate and you have just a spot in the middle. So think about like Hawaii is a hotspot volcano. It's in the middle of a plate, middle of that Pacific plate. So this one's probably going to be D, shallow, medium, deep focus earthquakes. Why is it that? If you think about the picture up above here is kind of describing what's happening there. If you have two plates sliding past each other, if we look at part A here, because these plates can lock up along this line where they're kind of running into one another, you can end up with really shallow earthquakes. So you could end up with an earthquake right here. You could end up with a medium earthquake right here, or you could end up with a really deep earthquake. So when you have subduction, two plates running into each other, you're going to end up with earthquakes at the surface and then all the way down the subduction zone. So this can keep going and get really, really deep focus earthquakes there. The little triangles are signifying the subduction zone, yeah. So They do actually show you which direction the subduction's happening. They will always point to where the subduction's going. I think. Notice how some of the triangles, even on this one right here, some of your triangles are pointing that way and then some of your triangles are pointing that way. So it just shows which way the subduction's kind of going. I wouldn't look too deeply into that. If I look at this picture, I see that I have this plate here is oceanic, and then I have some crust here, or continental, I guess would be a better word. So it looks like the small, thin oceanic plate is going under the much thicker continental plate. It's not actually... Oh, I see what you're saying. Which one is going under the other? So these are both showing divergent boundaries, which is incorrect. So we get rid of those automatically. And then we need to figure out which one's going under which. So you'd be looking at C, because you have the oceanic plate on the right, and then the continental plate over here. I would go with that. Uh, 68, 73, 78. Volcanoes are least likely to be found at... All right, so hot spot. If you have a plate and you have a hole in the middle of it, magma comes out, there's your hot spot. Transform fault is two plates that are sliding past one another. Kind of like so. That one's going that way, that one's going that way. This is transform. Spreading ridge is where you have two plates that are moving away from one another, and a subduction zone is what we just looked at. So, volcanoes are least likely. If we think about a transform boundary, there's nowhere for magma to rise up between those two things. If you have plates sliding past each other, you have two really thick on either side sections of plate. One's going this way, one's going that way. There's going to be no magma coming up through there. They're just sliding past each other. The other one's the hot spot. You have magma rising through the plate. Subduction, you get the melting and then volcanoes occurring, and then with a divergent plate boundary, the magma will rise up between them. So there you go. I'm thinking it's definitely a transform. All right, there were some additional questions here. Ava, I'm just reading your question. I think this is the next one. Symbiotic relationship between remoras and sharks. Seems like both species are benefiting from the relationship, but why do some people call it commensalism if it seems to be mutualism? That's a pretty specific example. You're welcome, Abby. The remora is benefiting because it has a place to live, essentially. How does the shark benefit from the remora in the scenario? What sort of benefit is the shark receiving? I don't know specifically that the shark receives a benefit from it. So I don't think the shark is necessarily getting like a cleaning from the remora or anything like that. I mean, I think remoras just kind of hang on, and then when there's kind of food around, it eats them. Think about it this way. If a shark didn't have a remora stuck to it, would the shark get all kind of covered in algae and things like that? Or sharks generally, maybe, I don't know, I'm not a shark expert, are they possibly shedding skin and keeping clean through some other method? Maybe they move fast or something like that. I don't know enough about remoras or sharks to comment on that, but I would assume that the remora has the place to live and the shark isn't receiving a great benefit from the situation. So I could see why you would call it commensalism. Basically, the shark isn't receiving a lot of benefit, whereas the remora has a place to live. When the shark starts to eat, sharks are messy eaters, it gets some food, things like that. So I think that's probably where I would go with that. In the case of mutualism, there has to be kind of an obvious benefit for both organisms in the relationship. So you have to have an obvious benefit for the shark and an obvious benefit from the remora. So the cleaning the teeth is, that's definitely going to be kind of mutualism, because the teeth of the animal get cleaned, it removes parasites and food that's kind of stuck in there, and then whatever's cleaning the teeth, like the shrimp or a fish, that receives a meal. So that's kind of a mutualism sort of thing. I think with the remora and the shark, we're assuming that the shark is receiving some benefit, but I'm not sure that it is. But that's a pretty specific example. Could kind of go either way. And again, I'm not a marine biologist, so commenting on that would be difficult. And that kind of leads into not everything's kind of really clean and clear cut. You might end up with some situations where it might not be obvious that one animal is receiving a benefit or not. There you go. Like the shark and the remora symbiotic relationship came up on a test. I don't think they're going to ask something that specific. You would have to know a lot of information about sharks and remoras. Unless they give you a big paragraph explaining that the shark and the remora both receive a benefit, then they're not going to ask a question like that. Now that I've said that, you're probably going to refer to some exam where it actually did come up, but unless it states that the remora is somehow benefiting the shark, I would go with commensalism. Typically with these types of questions, if you know the difference, you're going to be fine. It's not going to be a matter of, fine details and things like that. All right, so I got through Abby's questions. That's not a problem. It's a relevant question. I'm glad you asked. You'd have to go look it up. Avery, you wanted exam number 1. I don't remember which exam is number 1. Is this the exam you're referring to, Avery? The one that starts with, which of the following lists only abiotic factors? I have a feeling it might be. And if that's the one, then I can definitely go through those questions with you. Perfect, thank you, Avery. All right, you asked about, just scrolling up in my chat. I know you asked 32, but there are some other ones. Number 32, 19, 20, and 32. Did I get all those? Ava, fire away for sure. 19, 21, and 32. Okay. 19. Over time, each generation of a species of bacteria can become more resistant to an antibiotic used to fight it, resulting in the antibiotic losing effectiveness. This is an example of... all right, that's a good question. It's a way for the test to kind of test your knowledge of 4 different vocabulary terms. So do you know what predation means? Do you know what extinction means? Do you know what natural selection means? And biomagnification. So predation is where one organism eats all or part of another. Extinction is where one organism ceases to exist. Natural selection is sort of a genetic benefit in successive generations. And then biomagnification can mean a lot of things, but we talked about it specifically in the context of pollution. So as you get higher in a food chain, the concentration of chemicals gets higher as you go up. So which one of those sounds the best in this example? I'm probably going to go with C, natural selection. And why would that make sense? Well, the bacteria is dying because of the antibiotics. So let's say I, give an antibiotic to you and then the bacteria continues to live. Well, the really weak bacteria got killed. The ones that aren't weak, they survived. Now, all of the ones in the next generation are able to survive that type of antibiotic. If I give you a more powerful antibiotic and still more bacteria are able to survive that, well, everything that died, all their genetic information stops. And then everything that survived, their genetic information continues to get passed on to the next generation. And bacteria is a little bit different because of how they reproduce. But that's kind of what natural selection is. Favorable trait gets passed on to successive generations, or genetic information gets passed on. So yes, I would go with C there. (21) and 32. Looks like we went through this one. I think Ava actually asked about this a few classes ago. In order to slow the spread of the pine beetle, we burned some forest. 5 years later, which of the following statements would be true? This was a pretty tough question for sure. And I would go with I would eliminate the incorrect answers. Think about it that way. It maybe makes a bit more sense. I would say life had returned to the area. There'll be lots of grasses and plants growing. Animals move back in. Climax community will be established in 5 years. That usually takes, like in the time frame of 100 years to get to a climax community. And the mountain pine beetle will have proliferated in the area. That means it's going to spread really quickly. So, yeah, it's going to be the biodiversity one. But that's kind of like the least wrong answer. I don't know. Obviously, there's something I missed when talking about sort of biodiversity after an event. 32, which of the following compounds forms a basic solution when dissolved in water? This is going back to metal oxides and water and non-metal oxides. And water. Now, one of them produces an acid and one of them produces a base. And I see CSOH is already a base, so I'm thinking the answer is probably going to have a 3 in it. Now I just need to remember if a metal oxide in water produces an acid or a non-metal oxide in water produces an acid, and I don't remember. So we're going to have to go back and see if it's in the notes. Acids, pH indicators, unit 5, I'm pretty sure, second half. Metal oxides react with water to form bases. So a metal oxide and water gives us a base. All right. So now that I'm back here, I need to figure out which is my metal oxide. Barium's a metal. So metal oxide and water gives us a base. Non-metal oxide and water gives us an acid. Yeah, so 2 and 3. That's a hard question for sure. CSOH is already a base, so if I dissolve a base in water, it would form a basic solution. CO2 is a non-metal oxide, and that's going to give me an acid when dissolved in water. These are kind of these really obscure things that I don't even remember, but you just need to make a point of memorizing the difference between the two. Metal oxide and non-metal oxide is just that simple. If it says metal oxide, I'm going to have something attached to O. So in this case, BaO. There's your metal, there's your oxide. A non-metal oxide is going to be something like carbon or something from the right side of the staircase on the periodic table. All right. Avery, was that all of your questions? Did I get them all? I know Ava, I think, asked a few questions on the same exam. Earth science stuff. So I can go through that. I'm just looking if there's any other questions. Along the way, but I think that's kind of it. All right, so the earth science stuff for you on the same exam, Ava, and hopefully Avery, I covered everything you had questions about. If not, let me know. Down to the bottom we go. All right, so Ava, you asked about 73, 76, 79, 77 to 79. What occurs at X? This doesn't seem like a super tricky question. I guess the diagram looks a little bit different. Let's go with, you've answered it obviously, Ava. What did you think it was? I guess the volcanic island arc is the one that's kind of throwing me off. I have a feeling you probably answered this correctly, you just are a little bit unsure of it. Remember, we have the two plates moving apart because we have magma pushing up. So you're right, the ridge push occurs. That one's correct for sure. Volcanic island arc don't generally form at divergent plate boundaries. If we look at something like, I know this is sideways. Everywhere there's volcanoes here, you have convergent plate boundaries. So over here, you have two plates coming together, volcanoes in an arc, volcanoes in an arc. The Aleutian Islands are a great example of volcanic island arc up here, where you have convergent plate boundaries. So the answer is B, because you end up with volcanic island arcs happen at convergent boundaries. So get rid of that guy and you're left with 1 and 3. So that makes sense. 76. During the Triassic, the Atlantic Ocean was formed along the North American plate westward. 3 diagrams show what was occurring on the west coast of North America 200, 150, and 100 million years ago. Okie dokie. What conclusion can be made about the, holy cow, the intermontane belt 100 million years ago? All right, so this is not a nice question, is it? So this is the oldest, and this is the youngest. and we're talking about the 100 million years ago picture. So it's talking about the formation of the Atlantic Ocean. You'll notice here there's no volcanoes. Here there's some volcanoes, and then here there's two sets of volcanoes. The west coast of North America. Okay, so what conclusion can be made 100 million years ago? It's formed at a spreading ridge. No, we have convergence. 7060 thought it was D. Okay. It was an active volcanic region. That's looking okay. It's considered the remains of volcanic island arc and hotspot volcanoes. There's not a volcanic island arc really 100 million years ago. These are volcanoes on land, so we don't have islands. And then consist of the remains of volcanic island arc and a continental volcanic belt. I could see how it would be B or D. You have your volcanic island arc there. I'm looking at the Phaleron plate here and the Phaleron plate here. The insular plate gets kind of subducted and disappears. This is some serious business here. So this volcanic island arc actually gets turned into this one here, I'm thinking. So consisted of the remains maybe not. It's asking about specifically this belt here. I guess it's saying that they have the intermoraine belt here. Yeah, so it's going to be D because you have the belt that starts as island arc and then it is now on land because the islands, formed land, and then you have another volcanic belt there. That was all kinds of a tricky question. A lot of sort of processing there. Are they the same or different? If you look at the name of it, it's the same name. It started as islands, and then it kind of created land, and then now it's well onto the land. I don't know. I'm thinking letter B is wrong because it's specifically asking about this belt, but I'm thinking the majority of students would probably pick B, but I'm thinking D is the correct answer. I don't know why B just seems like it seems like there's two right answers and you need to pick the most correct answer. I think D is more specific than B, and I would go with D. That's definitely a hard one. I find that the most difficult ones are in the earth science section, maybe because it's kind of my weakest area. I always have trouble with them. 77, which of the diagrams shows evidence for continental drift theory? Remember, continental drift theory and plate tectonic theory are different things. We need to remember which is specific to continental drift and which is specific to plate tectonic. So continental drift was Alfred Wegener. He didn't know why they moved, he just thought they moved. And he used all of the things here, I believe, diagram 1, 2, and 3. So Pangea, matching fossils in diagram 1, and paleoglaciation diagram 3. So that would be D, you're right. Well, diagram 1 is just showing that you have these dinosaur fossils occurring on different continents. So this is, Australia, you have South America and Africa, this dinosaur there. So obviously when you guys get your exam, the diagrams will be nice and pretty and easy to read, but I could see how that would be a bit tricky given that. So 1, 2, and 3. Which of the following Aleutian Islands, 78, which of the following describes this island? Hotspot volcano, island arc volcano, continental volcano, mid-oceanic ridge. If you just remember Wagner did Pangaea, then the other two people, we had J. Wilson Tuzo and who's the other guy? Drawing a blank now. Continental drift theory. I can't believe I've forgotten the other guy's name. Wagner, Tuzo. Just know the difference between continental drift and plate tectonic theory, and you'll be okay. It's pretty rare that the last question's specific about names. Anyways, I can't think of the guy's name. You're right, 78 is B. It's an island arc. So you have a bunch of little islands, they're volcanoes, they're arcs. Yeah, there's going to be nothing specific to the people. If you know that Wagner was the continental drift guy, you're good to go. That one's good. And then 79, oh boy, talking about the Samoan Islands. Cluster earthquakes, blah, blah, blah. X should have been just east of the chain. Active volcano. So this is kind of the same thing as the Hawaiian Islands. Sorry, it just took me a second to read through those. So the islands are getting formed, the plate's moving across, the hotspot stays stationary, but the plate comes across and you get a new island being formed. The plate keeps moving, and then the oldest islands will be all weathered and smallest. The newest islands will be the biggest. It isn't a volcanic island arc because they're all in one line. Just like the Hawaiian Islands are in a straight line, they're not in a big arc. So it's going to be B because we don't want the island arc to be in there. So Samoan Islands right atop the moving Pacific plate, that's true. And a stationary hotspot is responsible for creating that island. 1 and 3. It's possible that earth science isn't your strongest because it isn't my strongest. Maybe I don't do a very good job of it. I think I need to do a better job of it. I think the questions in the provincial exam are generally more specific than the questions that are asked in the textbook and the course. So I think it's a bit of a combination of more difficult questions being asked in that section, as well as not great information about it in the actual course itself in the textbook. So what's the difference between the islands and the island arc? Let's go back to the plate tectonic pages. So the Aleutian Islands, the Aleutian Trench up here at the top of our map, it's not very good because this is a 2D image of it, but if you look at these on a map, the Aleutian Islands form a big arc. Kind of goes like that. And then if we scroll down, you can see that you have like Indonesia here is in a big arc, and Japan is in a big arc. So it turns out that the islands at subduction zones that get created are going to be in a big arc. It's just kind of how it works. If you think about two plates kind of bumping into one another, the plates are going to give way in the middle, I guess, more so than the edges. And you're going to get subduction happening. It's going down under, and then you get all your volcanoes forming in a big arc. Whereas something like Hawaii, you can kind of see it here, this is just in a straight line. And the Samoan Islands are on a hotspot, not on the map. A chain of shield volcanoes. Now you're really testing my knowledge about the types of volcanoes. I believe shield, I'm going to get shield and composite mixed up now. I don't want to say yes or no to that without looking up the definitions of those volcanoes. My mom was homeschooling. She made me focus on math because it was her favorite, less on art, so I guess that's a lot to do. Yeah, this is true. Try to be well-rounded in the sciences, but it's kind of hard sometimes. So if it's formed at a plate boundary like a subduction zone, it's going to be a volcanic island arc, but if it's formed at a chain of shield volcanoes over a hotspot, is it not a volcanic island arc? The hotspots happen in the middle of a plate, so the plate's just moving straight, and you're not going to get an arc of islands. You're just going to get a string of islands. So just like the image that we were just looking at here, these islands are all in a completely straight line. The hotspot produces an island, then the plate shifts, and then the hotspot produces a new island, hotspot produces a new island, and all those islands are going to be in a straight line. But when you have a subduction zone, when the plate goes under the other one, you're going to get a big arc. So think about it this way. Volcanic island arcs are going to happen at subduction zones where two plates are coming together and subducting. You're not going to get a volcanic island arc at a hotspot. I'm confident in saying that. I'm just double thinking my choices of words. So hotspots, just a hole in a plate, magma rises up, pushes its way through. Volcanic island arcs are going to happen anywhere you have subduction zone. Maybe I spent too much time focusing on hotspots. We talked about two in class. We talked about the Hawaiian Islands, then we talked about the hotspot under Yellowstone, that supervolcano just kind of lurking down there. Generally speaking, there's not going to be a lot of stuff on hot spots, but remember, a hot spot is a plate in the middle. You're going to have magma rising through. I don't think they would be called hotspot islands because the hotspot is only at one spot. Once the plate, if we look at the example here, you have your magma rising up here. At this last island, there's no magma rising here. There's nothing creating this island anymore. So this island is going to be weathered, and it's going to get really small and kind of washed into the sea. So volcanic hotspot islands is kind of a plural, but the hotspot's only one spot. Remember, that spot stays stationary and the plate slides across it, and then a new island gets formed, the plate keeps sliding, new island, plate keeps moving, new island. So the very last island, very end island, isn't getting created anymore. The hotspot's only pushing up, creating an island at this end. Hopefully that kind of makes sense between the hotspots. I know Abby asked a question about the difference between velocity time and distance time graphs, so I'd like to cover that for sure before we go. And just as a general question for anyone still sticking around, is there anything specific you'd want to go through in reference to any of the practice exams, the reviews, anything like that? I would be happy to go over that. I will go over for sure distance time, velocity time graphs. And if you have something else that you would like to see, if I've missed something, let me know and I would like to go over it. Rift eruptions or rift volcanoes occur over long cracks in the lithosphere. What is the nature of these cracks and how they differ from hot spots? Shield volcanoes form over hot spots and rift eruptions occur over the cracks. Is that a statement or a question, Ava? Are they hot spots? I suppose you could, I'm thinking we're confusing the definition of hot spot as happening in the middle of a plate and it's happening at a divergent plate boundary. A hot spot volcano, I mean, if you think about just hot spots in general, it's a weakness in the crust where magma is pushing its way through. If I have two plates, here's one plate, here's another plate, and I have magma pushing up in between them, if there's a weakness, I will end up with a volcano. But these plates are getting pushed apart, so the volcano is going to spread its magma, and then the plates are going to move further apart. So hotspots occur at weaknesses. If I have a divergent plate boundary, my plates will be very thin at one edge and very thick at the trailing edge. So because the crust is so thick, we get volcanoes and hotspots in the middle. I wouldn't consider those to be hotspots necessarily. Think of hotspots to be happening in the middle of a plate boundary. In the middle of a plate, not at a plate boundary. That might kind of organize your thoughts a little bit better on the difference between those two things. Eva, if you're good with that, I'm going to jump over to the difference between these position and velocity time graphs. This was obviously the last page on the Unit 9 learning guide with velocity time and position time graphs. So I think this is kind of the most complete set of different circumstances. It'd be easy to kind of discuss what's going on. Let's look at, I'll do this in green because I haven't used green yet. All right. I'm going to compare this one here up in the top right, velocity time graph, check my axes, and I'm going to compare it to this guy down here, which looks almost identical. Obviously, the y-intercept's a little bit higher on the other one. But maybe let's talk about the velocity time graph here at the top. So I don't have any numbers on the graph, but I can put numbers in. It doesn't matter what they are. Let's make this 5, and this up here is going to be 10. And then time starts at 0. Let's say this is 5 seconds, and let's say this is 10 seconds. So if I am going through this, I think at time 0, when this first starts, I'm already moving. So time 0, the velocity is going to be 5 meters per second. And of course, I just made that number up. All right, let's go to 5 seconds. What's my velocity going to be now? Well, it's about midway between 5 and 10, so my velocity is going to be 7.5 meters per second. And then I go at 10 seconds, my velocity is going to be about 10 meters per second. So if I were to describe to somebody what was going on this graph, without numbers, just in general, I'd say that I was starting by moving. My speed was increasing. I've gone from 5 to 7 to 10. I just made those numbers up, but the object is speeding up. So we have positive acceleration. and that is a velocity time graph. Exactly. So you have an increasing slope, positive slope on a velocity time graph is positive acceleration. If I go back to this guy down here, let's pick some numbers like -5, +5, and then 0 seconds. Let's make this 5 seconds and 10 seconds. T equals 0, my position is -5. At t equals 5 seconds, my position is 0. And at t is 10 seconds, my position is 10 meters. Okay, so let's describe what's going on here. I started to the left of an object. This is kind of like the tree picture I drew a few minutes ago. I went past the object, and now I'm moved beyond it. I don't know how fast I'm going. Well, I suppose I could figure it out. I have a constant slope. This is linear. And it's positive slope. And the slope of a position time graph is velocity. So I have an increasing, a positive slope, but that just means my velocity is constant. So here I have a constant velocity. The object isn't speeding up. It is moving in a positive direction, you're correct. So I'd say a constant velocity in a positive direction, all that is correct. If I compare that to something like the one just below it here, if I look at the slope, right here I have a really steep slope, right here I have a less steep slope, and right here I have a no slope. So if I can remember that the slope of a position time graph is velocity, this first little section here, I have a large, dyslexic day, large negative velocity. And then in the middle section here, I have a small negative velocity. And then here, I have a horizontal line. I have 0 velocity. So with this one below it, I was going really fast backwards. Then I was slowing down. I went from a large to a small, and then I went to 0. So everything's going backwards. I'm just slowing down, going backwards. And then hopefully that's kind of okay. Are you all right with that? I can keep going, or I can stop. You want to talk about a Wednesday, that's perfect, because it might be easier for you to explain it than me to just sit here and take shots at the dark to try to explain it to you. All right, it's 10:30. I have lots of free time, but if nobody has any other questions, we can call it a day there. And again, if you run into problems along the way, send me a message and I'll get back to you for sure. You can come in on Wednesday and we can go over anything, tie up any loose ends. If nobody has any other questions, then we can move on and call it a day. But if you guys have further questions, I'd be happy to go through them. For sure, Ava, we can talk about fusion. Just fire them into chat and I will definitely go through them. If you don't have any more questions, you can log out whenever you want. I won't be sad to see you go. I totally understand. And for sure, we'll see you on Friday. If not, on Wednesday. Hopefully, we see a few of you on Wednesday. Fusion. See you later, Anna, now that you have logged out, and Andrew. Does nuclear fusion reactions produce hazardous waste? The long and the short of it is no. Think about it as not producing hazardous waste. If you take a fusion reaction, you're going to take something like hydrogen and you're going to combine it with something like hydrogen. And it's going to react to produce some things. Let's keep it simple enough. Let's say it reacts to produce helium and a neutron. So we have two hydrogens. This is deuterium and this is just regular hydrogen. You end up with helium and a neutron. Now the neutrons kind of just go blasting off and get absorbed and contained within the fusion type of reactor. If it happens in the sun, they just get fired off into space or absorbed by other things that are in the star. But the byproducts are helium and neutrons. So neutrons could be dangerous if you're standing right next to it, but if we're talking about the things that are being produced, we end up with just helium. And it's not radioactive helium, it's just standard helium. 2 neutrons, 2 protons. My math's not exactly right here, but you end up with things that aren't radioactive. Whereas if you had something like uranium-235 and a neutron, and you combine these things together, you generally end up with barium and krypton. And barium and krypton are unstable. These guys are radioactive. So you also get a bunch of neutrons produced as well. Let's go with this. All right, so that is the difference between the fission and the fusion. Yeah, our sun is a relatively small star. I mean, it's big to us, but our sun can fuse up to, I forget what it can fuse up to. Just stars in general can fuse everything up to iron, which is like 26 on the periodic table, I believe. Just guessing. I have a periodic table, I might as well look at it. Yeah, 26. So the sun, our star, can fuse everything up to, stars in general can fuse things up to 26 protons. And then after that, you need a supernova. The reaction that I've shown here is something that happens in the sun. Our sun can fuse hydrogen, helium. I think it might even be able to fuse beryllium. I don't exactly remember, but our sun can fuse up to maybe like 5 or 6 on the periodic table, where larger stars can fuse bigger things. This is something that would happen in the sun, though, for sure. 2 different types of hydrogen being fused together. That would be a very common reaction in the sun. In our sun, if you had really high temperatures and pressures near the core, you could get things like helium fusing with hydrogen. You could get helium fusing with helium, other things like that. And Abby, you're right. The advantage of fusion is that the stuff that's produced is just helium. Helium gas is, people inhale it. It's not dangerous at all. Whereas something like barium or krypton that's produced in a fission reaction has a really long half-life, literally millions of years before it breaks down into something stable. So uranium-235 is how nuclear power and nuclear weapons are created. Yep, you get uranium-238 and 235 are both fissionable, and that's kind of what we base a lot of this stuff around. Plutonium's not naturally occurring, but uranium-235 will absorb a neutron and become plutonium, and then it's stable enough for us to use it. Uncontrolled chain reactions led to the creation of bombs. That's not what led to the creation. The idea was what led to the creation. It's not like we just kind of stumbled across it. It was theory first, and then it became reality after. People like Liz Meitner and Leo Szilard, they said, hey, if we take a really big nucleus like uranium, we might be able to break it down. And then they did some math and saw that there was a little bit of mass that got created to energy, and that's kind of where the idea came from. All right, thanks, Abby. Have a good afternoon. Uncontrolled chain reactions are what happens in bombs, though, yes. If we can control a chain reaction, that's what's happening in nuclear power plants. So that's the difference between those two. Is there anything else, Ava? Or does that kind of keep you going for now? Excellent. Have a great afternoon. Hopefully you don't have any more questions. I think you are well on your way. So we'll see you on Friday for sure.